Today we're going to look at applications of systems, in other words, word problems. Now, a lot of the times, my idea is if you can solve a word problem with one variable, go ahead and do it. Some problems lend themselves easier to two variables, and those are the types we're going to look at right now. In this first problem, it says the difference between twice one number and a lesser number is 21. Now, there's not necessarily a relationship between those two numbers there. Let's read the second sentence. The sum of the lesser number and twice the greater number is 27. So again, that doesn't give us comparability, or how can we express one number in terms of another as much. So this sets itself up for two variables. So let's go ahead and talk about the lesser number and the greater number. I'm going to call the lesser x and the greater y. And it says the difference between twice one number and the lesser number. So twice one number and the lesser number, it's a difference. So that guy's going to go second, is 21. And it said twice the other number. So 2y minus x is 21. And then it says the sum of the lesser, so the lesser was x, and twice the greater, that's y, is equal to 27. And we want to find those two numbers. Now notice, this sets itself up nicely for substitution, but also if I rearrange my variables in this case, so I say 2y minus x equals 21, and we know that addition is commutative, so I can switch the order, say 2y plus x is equal to 27. Notice this problem's all set up for addition, so I have 4y is equal to 48. Divide both sides by 4, and I get y is equal to 12. Plugging back into one of these two equations, I get x plus 2 times 12 is equal to 27. It's 24 plus x is equal to 27. Subtract 24 from both sides, and I get 3 is equal to x. So that's my lesser number. My greater number is 12. So once again, if I take twice my bigger number, subtract off the smaller number, I get 21, which is true. And then if I take my smaller number, and add to that twice my greater number, I get 24 and 3, which is 27, and this problem checks. Let's take a look at another problem that lends itself to this. At a meeting, you've got 7 more women than men. There are 43 total people there, and how many women are there and how many men are there in this group? I could actually do this with one variable because I have a comparable relationship with men and women, but for the sake of argument, let's just do this with two variables. So I'll do this W for women, M for men. So I know there are 7 more women than men. So if I say men plus 7 is equal to women, then there are 7 more women than men. That's what that means. There are 43 total people there, so the men plus the women is equal to 43. This is all set up for a substitution because I know what W equals. So I can say M plus 7, that's like my W, is equal to 43, or 2M plus 7 is 43. Subtracting 7 from both sides, I get 2M is equal to 36, and dividing by 2 to both sides, I get M equals 18. So there's 18 men. And if I go back up here and say 18 plus 7, I get my W. That's 25 women. And I check to see there are certainly 7 more women than men, and if I add the 2, I get a total of 43. So that checks out. So in this problem, you've got a book club charging a fixed cost per book and a membership fee, and after buying 6 books, Jake owes $17. After buying 10 books, he owes $25. You want to know the membership fee and the cost per book. So let's call our membership fee M and our cost per book C. And it says we've got the fixed cost, or the membership fee, plus 6 books. So 6 at a cost per book is equal to $17. And then if he has a membership fee and 10 books, then that's going to be $25. This problem's set up nicely for subtraction. So M minus M is 0. 6 minus 10 is negative 4. And 17 minus 25 is negative 8. Divide by negative 4. And I get the cost per book is $2. I need to substitute that back up to get the membership fee. So I have the membership plus 6 times 2 is equal to 17. That's M plus 12 is 17. Subtract 12. Get M equals 5. So the membership is 5 and the cost per is 2. Perimeter of a rectangular field is 1,040 yards and the length is 40 more than twice the width. So let's take a look. First of all, we know the perimeter is equal to 2 times the length plus 2 times the width. We learned that earlier in the year. And in this case, we know that the perimeter is 1040. So I can say 1040 is equal to 2L plus 2W. Now they give us some comparability here. The length is, or the length equals 40 more than twice the width. This problem's all set up for substitution because I know what L is equal to. So I have 1040 is equal to 2 times whatever the length is equal to, which is 2W plus 40 plus 2W. So 1040 is equal to 4W plus 80 plus 2W. 1040 equals 6W plus 80. Subtract 80 from both sides. I get 960 is equal to 6W. Take and divide 960 by 6, and I get 160. Whoops. And then I'd have to find out what the length is, so I could take and throw that back into this equation. Therefore, I've got the length equals 2 times 160 plus 40, or in this case 320 plus 40, or 360 is equal to the length. So 160 is the width, 360 is the length, and I'm done.